In this video, let's learn how we can graph the solution of an inequality, a linear inequality in two variables. I would like to also show two different methods to approach the solution here. So the first method I would like to show here, starting out by simply rewriting your inequality as an equation. So here, instead of 45x minus 40y less than, this is an inequality, less than 360, I'm going to purposely rewrite the inequality as an equation, as an equality. So equals 360. And so right here, after immediately switching your inequality into an equal sign, what we have now is an equation. And to remind that term, this equation here is a linear equation. It's a linear equation because once we're graphing it, it's going to become a line. That's why it's a linear equation. Of course, two variables, but in standard form. In standard form. So that's a terminology for that. Then now allow me to put in some grids, and we are going to graph this linear equation in standard form in this graphing space. And together we will graph the solution to our beginning inequality. And so at this point, we have learned to use either technologies or to make a hand sketch. So whichever I'm doing in the video here, if you are going with the technology, it's going to produce the same result. So graphing the line here, my bottom line here is graphing this line can be done either by making a hand sketch or using a technology such as Desmos or the TI calculator, TI 83, 84, or any advanced software on the computer. So here on this board, I am going to be sketching this using a hand sketch version. But once your equation being in standard form right here, then we can find the x-intercept and the y-intercept. The y-intercept is being on the y-axis, meaning x value equals 0. So when x value purposely equals 0, then your y value can be found by solving for this equation, 45 times 0, because x equals 0, and minus 40 times y equals 360. And so in that case, solving this equation for y value, we're looking at y value now equals a negative 9. So I now have the y-intercept being x equals 0, y equals negative 9. So that means with my graphing space here, negative 9 has to be 0, comma negative 9 is a point somewhere down here. This is 0 for x, negative 9 for y. And further, so this is the one of the intercept. We're going to also need to find the other intercept on the x-axis. The x-axis, the y-axis. And so now we're going to purposely let y value equal 0, because on the x-axis, y value equals 0. And in the meanwhile, we're going to find x value by solving this equation, 45x. Now x is the remaining unknowns, minus 45 times 0, because we already set y equals 0, equals 360. So this equation algebraically produced for us x equals 8. And so, meaning we have another intercept here on the x-axis, being y equals 0 and x equals 8. So 8 comma 0 is right here, this point. Eight comma 0. And so now it's just a matter of connecting the 2 points here as a line. So I'm trying to make my best to make the line really land into the 2 points right here. And so why am I using dotted line in this case? So remind yourself that the original inequality was 45x minus 40y being less than 360. So the original inequality was an inequality without equal signs. The simplest way to put it is that when your beginning inequality was an inequality without equal signs, then your line that we drew here after that equation has to be a dotted line. In other cases, when you're in other inequalities, if your inequalities have the equal signs with it, then the line that we're drawing here will be a solid line. But now, once we have the line, and knowing that we're using dotted line, the next step now is to properly shade the region. The region is either above or below. And how can we decide? So what we are about to do now is, and notice again that this method, we are starting out immediately with using the line, but our line is in standard form. And so what I'm doing now, allow me now to erase some of the writing we've had previously and return to a cleaner board here with only the sketch of the graph remains. But so once you got the graph of the line sketched, then we're going to be using a test point and simply just choose a random test point. So how about 3 for x and 5 for y? 3 for x and 5 for y. So 3 for x and 5 for y gives us the point 3 for x and 5 for y. It's this point right here. And we call this point, this approach here, we're using this point here as a test point. So the point physically on the plane, on the graphing space right here is above, is belong to the region that's above the line. But if we substitute this pair of value, this point into our left-hand side, and remind yourself that this is only a line, but in the beginning, 45x minus 40y was truly an inequality, and we want the left-hand side here being less than 360. So the plan about this testing point is that we're going to substitute this testing point into our left-hand side and to see if we can still maintain the required inequality here. And so 45 times 3 minus 40 times 5 substituted in for y. This left-hand side gives us, after calculation, negative 65 after calculation. And negative 65 after calculation is clearly less than 360 on the right-hand side of our inequality. So in other words, this testing point we chose satisfied our beginning requirements that the left-hand side with this point substituted in being less value than 360. So that means, and the point itself is on the upper region. That actually tells us a powerful thing that any other point, so now if we choose generally any other point with different coordinate pair that stays above this line here, will also satisfy this inequality, being less value, the left-hand side less value than 360. So that means now we are ready to make our final conclusion. The entire solution to this 45x minus 40y less than 360 is the entire region being sketched, being shaded above, because that's where our test point was, and our test point above the line satisfied this inequality. And that's the logic right there. So that means outside of that point, it's the entire region being above the line. And the line itself, we're not including it. That's why we are only using dotted line here. But it's the boundary, we can think of that as a boundary of this entire region. And so now, back to our beginning solution. back to our beginning problem. We want to graph the solution of this inequality, linear inequality in two variables, 45x minus 40y being less than 360. But allow me to introduce a different approach. So we are expecting the same exact graphical solution. It's just a different approach to get that graphical solution. So the different approach I'm about to introduce here is that right here from our inequality, I am going to spend some time and spend a few steps. So these are my steps right here. 45x minus 40y at start being less than 360. My first step, I am going to subtract 45x from both sides because I want to apply the steps that eventually only leave my y term on one side and everything else is going to the opposite side, and that's what I'm attempting. So I'm trying to bring the 45x term to the opposite side. And so now, after subtracting 45x from both sides, and I have to remind a couple algebraic properties that adding or subtracting one expression to both sides of an inequality will not change your inequality direction, meaning it's still in the next step, or the inequality we are about to produce here remains the same direction. So now 45x on the left hand side cancels. We have what remains here, negative 40y being less than, on the right hand side now we produce minus 45x plus 360. And as I said, the inequality did not change direction. The next step I'm doing is to divide both sides by, because remember the goal here is to eventually have only one variable y, one singular variable y, coefficient 1 on the left hand side. And so to achieve that, we are going to divide both sides this time by a negative 40. So I am going to divide by a negative 40 to the first term on the right hand side, and also divide by a negative 40 to the second term on my right hand side. But so now another property of inequality to be reminded, that anytime working with an inequality and your inequality is being divided by a negative number, that's why in this case right here, for this current step, I am writing that negative number as a special color, red color, to make it a little special. But canceling dividing both sides, or sometimes multiplying by a negative to both sides, we actually need to change the inequality in the following step. So now, for now, just laying it down, and the plan here is to divide both sides throughout all terms by the negative number. So negative 40 on the left hand side cancels with negative 40, giving me y. The left hand side, negative 45, reduces with negative 40, gives me a positive 9 over 8. X 360, positive 360 reduces with negative 40, gives me now a term negative 9. And as I said earlier, anytime we are dividing both sides of an inequality by a negative number, or multiplying both sides of an inequality by a negative number, then the inequality is going to change direction. So here's our left hand side, and here's our right hand side of the inequality. But now the inequality sign between them changed direction. So now, after rearranging our inequality, now it reads y variable is greater than 9 over 8x minus 9. And so now we will be graphing the solution of this inequality, this rearranged inequality, on the graphing space. Now with our inequality rearranged to be y is greater than 8x minus 8, 9, then we are ready to graph the solution. And so the first thing is to switch this, change that inequality sign into the equal sign, so that we are pretending that what we have here is a line. So think about, we are now going to graph the line y equals 9 over 8x minus 9 first. And so this line here has a slope being positive 9 over 8 with a y-intercept being negative 9. So in this y-intercept form of our line of equation, then negative 9 is at the bottom here. We have a point there, and that point is going to be coordinated at 0 for x, minus 9 for y. And the next step, once we've had the y-intercept nailed down right here on our y-axis, then the next step now is to drop another point, a second point, so that it makes a slope positive 9 over 8. And so think about from where this point is, we're going to go over to the right-hand side, 8 values, and go up by 9 values. So that would land us into the other point of being, which is right here. So raise up by 9, rise by 9, and over by 8. And so now I'm going to go ahead and connect my line. And without a ruler, I hope I'm going to be making a closing up, going through right here, but that's my line. So once again, the reason I'm using dotted line here for my line is simply because we only drawing the line based on this equation, but in the end, our inequality did not have the equal sign. And so now we are going to only use a dotted line, as the inequality originally only had came without equal sign. But now the advantage, we did have to spend quite a few steps to derive and arrive at this slope intercept form of our inequality. However, once we had it made to that step there, then we don't need to use the test point, because as the way how the inequality is reading right now directly, then all we need to do now is just make a shading that's completely above this line. So here's our solution. Here's our region that's indicating the solution of this inequality, y greater than 9 over 8x minus 9. Or equivalently, this is the same as that equation originally, 45x minus 40y being less than 360. So these two equations, that equation and this equation are the same, and they all lead to this graph of the solution.